So chapter 8, we're going to learn all about acids and bases. The first thing that we need to do in order to learn about them is find out what they are. Okay, there's a definition of acid and bases, but before we do that, let's look at one way to easily recognize some acids and some bases. Many acids have a formula that you can recognize just from the formula. For instance, hydrochloric acid. It's an acid and it starts with a hydrogen in the formula. And many of our acids do that. So that's an easy way to recognize an acid. Many of our bases are metal hydroxides. So what do we see? It must be a metal in front and then hydroxide as the following polyatomic ion. But that's not as general as we can be. There's a more general way of recognizing an acid, and that is by what it does. There's this Arrhenius definition. The name Arrhenius is not important, but what is important is that an acid produces the hydrogen ion in solution. So anything that produces hydrogen ions when put into water is considered to be an acid. Likewise, when a base, for instance sodium hydroxide, is put into water, it produces hydroxide. So we can define a base as that which produces hydroxide in water. This definition sometimes doesn't cover all of our acids and bases. For instance, the hydrogen ion doesn't really even exist in water. What exists in water? Well, that when hydrochloric acid gives up its hydrogen ion, what happens is actually that water is taking it. And so what's formed is not the hydrogen ion, but the hydronium ion. But if we discuss hydrogen ions instead, it is a lot easier than trying to look at the hydronium ion every time. Now, some people might prefer to look at the hydronium ion and it's more accurate, but a hydrogen ion is simpler. And so when we see a hydrogen ion, we will recognize it doesn't really exist in water, and what actually exists is the hydronium ion. Likewise, when you see the hydronium ion, you can think, oh, well, that's equivalent to a hydrogen ion. So we've been writing this hydrogen ion for you and saying it, but we really don't call it that much. We call it something else. So what do we call this hydrogen ion usually? Well, let's think about what is this hydrogen ion. It is a hydrogen atom with a positive charge, right? Well, what's in a hydrogen atom? Well, in a hydrogen atom you have a proton and an electron. How do you make hydrogen have a positive charge? Well, we remove the electron, right? What does that leave? That leaves a proton. And that is why we call the hydrogen ion a proton. So you're going to hear me saying proton from now on. And what do you think when I say proton? You think this hydrogen ion. Okay. Here's a more general definition, and that's called a Bronsted-Lowry acid and base. The Bronsted-Lowry acid is a proton donor, meaning it gives a proton. A Bronsted-Lowry base is a proton acceptor. That means it takes a proton. So if I look at something in water, I can look and see what is it doing, and then I will know whether it's an acid or base. Let's look at an example. Here is hydrochloric acid. You recognize it's an acid because it starts with a hydrogen. Well, let's look and see what happens as hydrochloric acid goes over here. Do you see the hydrogen came off of the chloride? That means it is giving up a proton. When you give up a proton, you're an acid. So this is an acid. Now let's look at the water. The water, when it goes over here, it's taking a proton from the hydrochloric acid. Well, that's the definition of a base, a proton acceptor. So water accepts a proton, and so it is a base. People don't tend to think of water as being either an acid or base because they know pure water is considered neutral, but water at times acts as a base and water at times acts as an acid. Most of the time we do consider water to be neutral. Okay, an acid must contain a hydrogen atom if it's going to give up a proton. So we do see acids all the time that have their formulas start with hydrogen because they can give up a proton. There are some others, like acetic acid right here, that have a hydrogen on an oxygen and it can come off. These do not come off. But this hydrogen can come off as a proton. And so not all of our acids actually have this formula of hydrogen starting in the beginning. Sometimes we'll force a compound like this into that format by writing the hydrogen first, but that's not really the way chemists usually write the formula. Okay, a base is going to be something that takes a proton. For something to take a proton, there has to be a lone pair to grab the proton. So let's just look at this. Ammonia can react with water, and look, it's producing hydroxide. So right there, it's defined as a base because it produces hydroxide and water. How else can it be defined, though? If I look as it goes from here to here, it took a proton. So that means ammonia is a base. What is the water acting as? Well, look what happened to the water. As it goes from here to here, it gave up a proton. Well, that means it's an acid. See, I told you, water can sometimes act as an acid, sometimes it can act as a base. In general, we consider water, when pure, to be neutral, but it can act as an acid or act as a base in reactions. Okay, what are some common bases? Well, ammonia, water. Here are those metal hydroxides that I told you that we often will recognize as bases. The hydroxide is what makes it a base here. Here it's because there's these lone pairs on an oxygen or a nitrogen. Let's look at a typical reaction. Here's a general formula for any acid and a general formula for any base. What happens? The acid gives up a proton and makes the anion here. The base takes a proton and makes this formula. So this is an acid and that is a base. This electron pair stays on the hydrogen because H plus goes off. That's why this has a negative charge. Really, just look at it this way. If you take an H plus off this acid, which is neutral, what's left behind must be negative. Likewise, this is neutral. If it gains a proton, it must be positive. All right, now any acid that loses a proton makes a compound on the other side that has a non-bonding pair. Okay, any base with a non-bonding pair that gains a proton makes this compound. You notice there's a double arrow. We're showing this being an acid and this being a base because they're going in the forward reaction. But look what happens to this thing that used to be the acid when it goes back this way. If I look at this going back this way, you see that it gains a proton. That makes it a base. And if you look at this moving back this way, you see it gives up a proton. That makes it an acid. But because these two are pairs, they're connected by the base of the thing, this and this are called conjugates, and we'll say this is the acid and this is its conjugate base. This is the base and that's the conjugate acid. Here's another example. Here is hydrobromic acid reacting with water. What does the water do? The water grabs a proton and makes a hydronium ion. Remember, that's just the same as H+, isn't it? It behaves the same as it. Okay? What happens here with the hydrobromic acid, it goes over and makes bromide and gives up a proton. So the hydrobromic acid gives up a proton to become bromide. That is its conjugate base. The base gains a proton to make the hydronium ion. That's its conjugate acid. And we say they are conjugate acid-base pairs. Now, how is it you figure out what is a conjugate acid or what is a conjugate base? It's really very easy. You take the acid, any acid, and you take off the hydrogen ion. So you're taking off H+. What must be left behind? If I take a plus away from this, I must leave a negative behind. And of course, I'm taking off the hydrogen. So all you have to do to figure out what your conjugate base is of an acid is to remove a proton. Likewise, how do I figure out the conjugate acid of a base? I take this base and I add a proton to it, and that just makes a conjugate acid. It's a very easy process to figure out the conjugate acids and conjugate bases. So now, knowing this, you figure it out. What is a conjugate base of carbonic acid? To make the conjugate base of carbonic acid, all we have to do is remove a proton. So you remove a hydrogen and you remove a positive charge, that leaves a negative. So what is the conjugate base of carbonic acid? The conjugate base of carbonic acid is, all you have to do is take away this proton, take it off. That removes one hydrogen. You see it's one hydrogen down. And since I have a positive charge on that, that's going to have to leave a negative charge behind on the carbonic acid. On the bicarbonate. So what is the conjugate base of carbonic acid? Bicarbonate. What is the conjugate acid of ammonia? Well, I give you a big hint by showing you this problem. But look, all I have to do is take this and add an H+ to the formula. And what do I get? That right there. What is the conjugate acid of hydroxide? All I have to do is take this formula and add a proton to it. So I can do this and add a proton to it, and what do I get? I get HOH. Some people don't like looking at water that way, so you can write it as H2O, and that's great.